For your second homework assignment, you will be recreating your Curvilinear project from your Foundations class. You'll recall that you started with a block of wood and you cut some type of a curvy shape into it, like this, and then in a perpendicular direction you cut a completely different curvy shape to result in an object that was shaped like this. An interesting property of this, because the cuts are going in perpendicular directions, is that if we take a cross section anywhere through this construction, we can see that the cross section is always an ever-changing rectangular shape. From the feature tree, we can see that this is a pretty simple assignment. It consists, as far as the solids are concerned, of an extrusion to create this shape and a cut to remove the excess material to create this shape. The complexity in this assignment comes from learning how to draw the splines to create these shapes, and also scanning in images of your original project that you will be using to follow when you draw those splines. So here I will turn on my sketches and show that what's been entered into this file is a scanned in picture from the original homework assignment, which indicates the shape. I'll roll this back, which indicates the shape of my object when viewed from the front view, and a scanned in picture which indicates the shape when viewed from the top view. And you'll be drawing sketches that emulate these shapes. The other interesting thing about this assignment is that you have to make sure that whatever the length is of the scanned in view from the front has to identically match the length of the scanned in view from the top, because these two views actually represent the same three-dimensional object. So if they are a particular length in one view, they obviously have to be the same length in the other view. This means not only making the images the same length, but also making sure that when we make our actual sketches, that we have to have some sort of relation set up to guarantee that the endpoint of one sketch is in alignment with the endpoint of the other sketch in the x-axis. To do this assignment, I have to do a little preparation ahead of time. What I have to do is get my original sketches from my Foundations project and scan them in. Here, for example, is the sketch that you just saw that was ported into Solidworks. This was scanned in and then scaled to the particular dimension that I want it to be in Photoshop. So in this case, the image, when scaled at 1:1, was 9.24 inches in this direction. So that's what I set my image size to in Photoshop. And the other very important thing is I made sure that the boundaries of the picture exactly match the size of the image. So if the image itself, the curvy lines, are 9.24 inches wide, I also made sure that the image file itself was 9.24 inches wide as well, by very tightly clipping it to the edges here, 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 and here. That way we guarantee that the image file size and the actual image on it are exactly the same size. Similarly, I did the same thing for the view of my Curvilinear for the top view. Once again, I made sure that this was very tightly bounded or clipped back all the way to the edges of the image, and also made sure that this image was 9.24 inches wide. Yours will be different, of course, but I have to make sure that if my front view is 9.24, that my top view is as well. The other thing you want to think about is how much resolution you want in your image file. I find that an image that's simple like this only needs to be about 1 to 200 dots per inch. If you get an image file too big that you insert into Solidworks, you'll inadvertently make your Solidworks file very large. Remember, SolidWorks has to uncompress any JPEGs that you insert into it, so even though it looks like a small file as a JPEG, it actually becomes a very large file once it comes into SolidWorks. Going back to SolidWorks now, I'll give a brief overview of how to insert a picture into SolidWorks, and I'll go over this in more detail in a separate video. On the front plane, just draw a sketch. What I'm going to do is go to Tools, Sketch Tools, down at the very bottom, which unfortunately you're not going to be able to see in this video. We're going to go down to Sketch Picture. This menu bar is so long that it's running off the bottom of my video window, so you can't see it, but it's the second to the last command at the bottom of this menu. When I select Sketch Picture, it allows me to browse to my JPEG file that I'm going to insert into the sketch. And what it does is it automatically drops the lower left corner of the sketch onto the origin, and for reasons I won't go into now, it will bring it in at a dimension that is almost always different from what you set in Photoshop. Don't worry about this, just simply clear this dimension out and type in the size that you want this image to be. In my case, I want it to be 9.24. Lock aspect ratio has to be checked and will automatically change the vertical dimension as well. I hit enter, and that scales my picture to the same size that I had originally set it in Photoshop. I might also find it convenient to make this image somewhat transparent so that when I'm tracing over it later on, these dark lines don't block my view of what I'm actually drawing. So I'm going to check on full image, which gives me a transparency control, and I'm going to drag this to about 0.8. You can see that this fades out a bit, and then I can see through this image that I've inserted. I'll finish the sketch picture and finish the sketch itself. Now we see on sketch 1, if I open that up, I have this sketch picture which has been inserted into it. Just by double clicking on the sketch picture in the feature tree, I can bring up these parameters again that can allow me to adjust the transparency and the size, and we'll later see the position of the image in the sketch. The next thing to do is drop the top view sketch onto the top plane. So I'm going to highlight the top plane, Sketch, and once again go to Tools, Sketch Tools, and again you can't see it, Sketch Picture down at the bottom. This time I'm going to select my top image, and again it brings it in at a funny size. I'm going to make sure it's the same size as my front image, 9.24. Now we see that this size matches the size of my front image. Now there's two things here. First of all, you might have noticed that I forgot to change the transparency on this image. Also, this pointy end of my rectilinear in this view is the same as this pointy end in this view. It would be kind of nice then to have the pointed end of my curvilinear shape completely align both in the top view and the front view right here at the origin. It's not absolutely necessary, it's just a nice to have, and if I leave this where it is, it just means that the position of the object I create will just be in a slightly different spot, but it won't change the shape. I'm going to go and double click on the image, which brings up the property box again for the sketch picture. And the first thing I'm going to do is change that transparency to about 0.8. And I have another control here which allows me to control both the X position and the Y position of the image. What I want to do is pull this image down so that this point aligns with my origin. So that's the Y image control. If I click on the up arrow, we see we move the image upward. Click on the down arrow, move it downward. So I'll just keep moving this down. And this is really just by eye. I'll zoom in a little closer. And that looks pretty good. If I come down 1.3 inches, that gets this point appearing to be right on top of the origin. So now we're ready to go. We've got a front view and a top view, and both of them meet right at this point at the origin. The pointy end in this view, the pointy end in this view. Both are 9.24 inches wide, so that this point here and this point here are both the same distance away from the origin in the x direction. So I'm going to start with the front view. And I'm going to draw a completely new sketch on the front plane using my spline tool. I'm going to start at the origin and just trace by eye over the lines in my JPEG images. And unfortunately, there's no way to make an actual relation between a JPEG image and my sketch lines. We just have to do this by eye, and also the knowledge that this object was supposed to be 9.24 inches wide. So you'll learn that it's not practical with splines to dimension every single point, but it's very good practice to dimension at least the endpoints of the spline and any points that represent the overall size of the object. So I'm going to catch this endpoint here, this endpoint here. Remember, we decided that this would be 9.24 inches wide, so even if my sketch doesn't perfectly match up, I do want to make sure that the dimension I type in is the amount that I decided I wanted this object to be, which in this case is 9.24. So then I can add maybe a dimension that represents the top point, and perhaps a dimension that represents the height of this corner point. When you're working with splines, it's often very difficult to get all the lines to go black. You might just have to accept that, otherwise you have to dimension to every single spline point. So now what I want to do is extrude this shape, in this case in both directions, and extrude enough material to allow for this shape to later on to be cut away. So that means that I need to extrude at least as far as this point here in this direction, and at least as far as this point here in this direction. There's no harm in going extra far, since we're going to just be taking that excess material away anyway. So here I'll just do an extrude. It's going to be a two-direction extrude in my case. You see what I've done is gone well beyond this point here in direction 2. I've gone well beyond this point here. So that's my first feature. The next step is going to be to draw the top view shape, which is going to be used to cut away all the excess material around the perimeter. As you can see, now that we've done this extrusion, we actually can't even see our JPEG image down below. So we have a couple of choices. One is to draw from below when we make our sketch, or another is just simply to go in a wireframe mode, which can be found here under Display Style, and just change to wireframe, which allows us to see through our solid object. Before I do any of this, I want to add a plane at the very end of my object here that's going to represent the maximum 9.24 inch dimension that can be used as a reference when I draw my second sketch. I'm going to parametrically tie it to the first created feature here, so that if for some reason I were to change the length of this in the front view, it would automatically change in the top view at the same time. Adding this plane is not absolutely necessary, but some people might find this conceptually a little easier to understand. So I'm going to show my right plane here to demonstrate this. I'm going to go into Reference Geometry, Plane. For my first reference, I'm going to select my right plane. In my second reference, I'm going to select this corner point. It can be either this point here or it can be this point here, but what it will do is give me a plane that's parallel to the right plane and passing through this point simultaneously. Because this point was 9.24 inches away from the origin, this plane will also be 9.24 inches away from the origin. And it can be used as a convenient reference when we go to draw our top sketch. So going back into wireframe mode, here under Display Style, we'll look at the top view. We'll go ahead and click on the top plane, Sketch, and we'll go ahead and start drawing our splines to create this shape. You'll notice I'm starting at the origin, and I'm going to drag this point out to here somewhere. I'm going to purposely make a coincident relation between this plane and this point. That guarantees that no matter what the distance was in this direction on the front view sketch, it will be identical on our top view sketch. The other choice was to make a 9.24 dimension in this sketch as well, but if for some reason the front view sketch were to change, it would not automatically update in this top view sketch. Continuing on, we'll just draw a quick spline here. And then I won't do it here, but we want to add a few dimensions, maybe some dimensions from here to here so that we can control the width, and our length is already completely controlled. We could have avoided adding this plane altogether if we wanted to. I'll just go back into shaded mode, and instead of creating a separate plane and then making a coincident relation to the plane, I could have also simply made a coincident relation to this horizontal line that was created from this extrusion. But some people find that a little confusing at first, just because of the fact that this line or edge is well above this point in three-dimensional space. But when we look at them from a top view, we see that they are actually lined up with each other. So this is the last sketch, and what we want to do is remove all this excess material to the outside of this two-dimensional boundary that we've created. So this is going to be using the extruded cut command, which we're all familiar with. But normally the default whenever you create an enclosed area is to cut to the inside of the enclosed area. In this case we want to say flip side to cut. What it's going to do is cut away all the material to the outside of the enclosed area. We also see that this is cutting downward. Of course we want to cut upward because there's nothing downward to cut. So I'm going to flip the direction on the blind here, and I'm going to change from blind to through all to guarantee that everything is cut through all the way. Check mark, and there's my final shape. And then just to double check this, I'm going to click on the right plane. I'm going to go into cross-section mode. I'm just going to drag my cross-sectional plane and make sure that everywhere I look, the cross-section is some type of a rectangular shape. If this blue cross-section was not rectangular anywhere, it would mean that something has gone terribly awry with your homework assignment.